Alrighty, hello and welcome back. Alright, so for our second lesson this year, we're going to talk about how to evaluate expressions, right? So last time we talked a little bit about order of operations and how to kind of simplify them down. Evaluating is basically not that different, it's just one step further. Right, so these definitions right up at the top, right, we've already talked about those, right? An expression is a math sort of sentence without an equal sign. If it had an equal sign, it'd be an equation. And then evaluating is kind of solving it, right? Getting it to just one number answer, right? We used order of operations last time to do that. When we're evaluating expressions in the full sense, right, that means that we're going to start off by substituting numbers in for the matching variables and then using order of operations, right? So this we've already done, right? The only new thing is that step where we're plugging numbers in, right? So let's take a look. If we wanted to evaluate this expression using the order of operations, right, it's saying 4x plus 2 when x equals 5. So when x equals 5 just means that I'm going to take this 5 and put it in where there was an x. All right, so let me do that. So 4, there was an x, so I'm going to put a 5, and then plus 2. Now something about that doesn't seem quite right. This doesn't seem like it should be 45 plus 2, right? So something that you might remember from last time is that, when you've got a coefficient like that 4 in front of the x, there's actually multiplication going on there, right? That's 4 times x. So instead of writing 45, we're going to write 4 times 5. Right? I'm going to put it in parentheses just like that, which is not a bad habit to get into, right? When you're plugging in a variable, when we're evaluating, putting parentheses around it is a good way to make sure that you're doing the right thing to it, right? Because again, we don't want 45, we want 4 times that x, so 4 times 5, and then plus 2. Right? So just like on the last bit, right? Order of operations tells me that I should be doing this multiplication first. So 4 times 5 is going to give me 20. And then add that 2. It's going to give me 22. Right? Not too bad. Easy peasy. Right? So what happens when you get something like this, right? This looks a little bit scarier, right? It's got that exponent of 3 in there. Right? But again, we know that we're taking x to the third minus 11 when x is equal to 3. So again, all that means is that I'm going to plug 3 in where there's an x. Right? So 3 to the third minus 11. Right? Now, if you put parentheses around it, that's not going to change anything. In fact, that's probably a better habit to get into, right? In this case, because everything's positive, like the 3 is positive, you don't really need it. You'll eventually get into a habit where you'll kind of understand when you do and don't need them, right? But for right now, let's start with just putting it in parentheses and we plug it in and calling it good from there. So now I've got 3 to the third, right? So that's an exponent. We need to take care of that first. So 3 to the third power, right? When we put something to the third power, that means that we're multiplying it by itself that many times, right? So that's 3 times another 3. Right? So when we're multiplying all these together, right, you can take it one chunk at a time. 3 times 3 gives you 9. 9 times that other 3 gives you 27. Right, so that's what we're going to get out of this. This is now 27 minus 11. Right, when we take that last step, it's going to end us up at 16. Right, so again, we're not really doing much that's different from what we did last time with order of operations. We're just taking that extra step of like plugging a number in for the variable. All right. Ooh, something like this does look quite a bit scarier, right? The only difference is that there's a couple different places we're plugging in for the variable. So what we're doing is we're trying to figure out x minus, and then in parentheses, 3 minus x with a squared when x is equal to 8. All right, so again, first things first. I'm going to plug in wherever I had an x. Parentheses, there's an 8. Minus 3 minus where that other x was, and then squared. All right, so you might remember in the last lesson, right, we talked about how I think we had a problem where it was -1 times -7, and they were in their own parentheses, kind of like what we've got here, right? We kind of left them that way because we wanted to make sure that negative was kind of grouped up with it, right? We wanted to make sure that negative didn't disappear anywhere. In the problem we're working on now, these 8s are just positive 8s, right? We don't really need the parentheses around them, right? So in this case, we're actually just going to drop those. So my problem will look a little bit cleaner. Looks just like that, right? I haven't changed anything about it, right? Nothing is really different. Right? All I did was I just dropped the parentheses around those 8s and made it look a little nicer. Right? So from here, right, same old deal. Order of operations. I've got some parentheses here. We've got 3 minus 8. Right, so we've got 8 minus, and then that stuff in the parentheses, 3 minus 8 is going to bring us down to negative 5. And again, in the last lesson, we talked about imagining it like an elevator. You're on the 3rd floor, right? You're on the 3rd floor, and then you're going down 8 floors, right? So you're going to end up in the 5th basement level. Right? So now, right, this is where a calculator can come in handy, right? Because this gets a little tricky. That negative 5 is in parentheses, and we're going to square it. So I've got a calculator here. Look at that. It's fancy. And if I go ahead and I take my calculator and I plug in negative 5 to the 2nd power, let's see what it gives me. It's going to spit me out with 25. Now let's take a quick second and see what would happen if I tried to plug that in without the parentheses. Oops, not plus. Enter. Ooh, weird. All right, so what's going on here is that calculators are not as smart as we are, right? I really hate to say it, right? But we are smarter than the calculators. They're faster, like almost all the time. They're faster than we are, but we're smarter than they are. So when I've got negative 5 squared in parentheses, that's telling me that I'm going to be taking negative 5 times another negative 5. Those two negatives cancel each other out, and that gives me 25. All right? So if I gave you a problem that looked like this, you might say, oh yeah, negative 5 squared. Negative 5 times negative 5 is positive 25. The calculator doesn't think that way. The calculator thinks that it's more like this. It's doing 5 squared and then just slapping a negative on the front end of that. Right? So something to be careful of. Don't always trust the calculator, and if you do, right, make sure that you're plugging it in exactly as your problem shows, right? So in this case, that's parentheses and then the squared on the outside, kind of like I showed on that first example on the calculator there, right? Negative 5 in parentheses, then squared. All right, so that's all to say that that gives us 25, right? Bring along that 8 minus that was there before. And then 8 minus 25, we're going to do that next. It's going to bring us down to negative 17. And there we go. And then we're done. Right. So again, couple little tricky things when you're plugging these in, right? Some funky stuff can pop up, but take it slow, think about what you're doing, and most importantly, keep track of what you're doing from step to step, right? You'll notice that I wrote this same 8 several times, right? But I don't want to forget it at any point, right? It's all about being organized with order of operations. Okay. Let's try another one out. Right, we've got 5 minus 12 divided by x plus 4x. Right, so notice that when we got to this part right here, I said 12 divided by x. Right, because fractions are just division, right? I know that they're a little scary, but we got this. Right, we're plugging 6 in for x. And when I do that, it's going to look something like this. 5 minus 12 over, again, we're plugging in that 6, plus 4 times that 6. Okay, so again, same kind of deal as on the last one. These parentheses can kind of go away. Right? I don't really super need them. Right? Oops, actually that one I do. Don't erase too much. Right? This one is okay to erase because it's just kind of doing its own thing down there. These other ones near the 4, I'm keeping because I need to make sure that I'm still multiplying, right? That's 4 times 6, not 46. All right, so I almost made a mistake there. It's really easy to do. All right, so order of operations, thinking about parentheses first. These are the only parentheses I got. and I can't do anything in them, so we're going to move along. I don't have any exponents, so that's pretty nice. So next step is multiplication and division. All right, so whichever one you run into first, moving from left to right. So the first thing I'm seeing is that I've got this division here, right? Fractions are just division. So this is 5 minus 12 divided by 6. All right, that's going to spit me out with just 2. And actually, let's make that the same color. Let's keep everything consistent. All right, and then bringing along that 4 times 6. All right, that 4 times 6 is what we're doing next, right? It's that multiplication there. 4 times 6 is going to give me 24. All right, cool. All right, so you might notice I ran out of room. I'm going to bring this right on over, writing down the same thing. Right, it was 5 minus 2 plus 24. Okay, so now that we're done with multiplication and division, all we've got left is addition and subtraction. Right, again, moving from left to right, whichever ones we run into first. So 5 minus 2 is going to give me 3. All right, bring along that plus 24. Smush those together. 3 plus 24 is 27. And to quote what I hear in classrooms, we Gucci, fam. All right, that's it. We're done. Sorry for that. All right. So, again, plugging it in, working through it one step at a time. Okay. Things can sometimes get a little trickier with something sort of like this, right? But again, as long as you stay organized, there's not that much to worry about, to be honest. Right? So we've got 5x plus 7, and then in parentheses, negative 3y minus 7. So this one has an x equal to 4 and a y equal to negative 5. All right? So we got to be real careful to plug the right things in. So I'm going to plug in for my x's, right? That's 5 times x, which is 4. Bring everything else along, plus 7, parentheses, negative 3. And then this is where the y is going to go in, right, which is negative 5. All right, so I know it looks like a little bit of a mess, right? Let's take it one step at a time. So first things first, I've got some parentheses here, right? So I'm looking at this big chunk of parentheses. When I hop inside there, right, then I'm thinking about, all right, what do I need to do first? We've got some multiplication over here. Or I could start by doing some sort of subtraction. Right, we're going to start with the multiplication piece. Right, so this chunk right here is negative 3 times negative 5. And so let's bring everything else down. Right, remember to stay organized. Negative 3 times negative 5 is going to give me positive 15. Right, again, bring along that minus 7. Right, still in those parentheses, now we're going to take care of that subtraction. Right, so this is 5 times 4 plus 7. Then on the inside of there, 15 minus 7 is going to give us 8. All right. Looking much better already, right? Now all we've got is we've got 2 little bits of multiplication to do, and then we're going to add them together with that plus sign in the middle. All right, same kind of deal. I'm sort of running out of space. I'm just going to pop this over here. All right. Again, not changing anything. Just rewriting so I have a little bit more space underneath. Okay, so we're going to take care of this multiplication. 5 times 4 is going to give us 20. If you're feeling up to it, we can also take care of that multiplication at the same time. 7 times 8 is 56. And don't forget that plus sign that goes in between those two chunks. All right, last but not least, 20 plus 56 is 76. That's all we got to get through. And I know that when I say, that's all we got to get through, you're like, oh my gosh, that was a slog. That took forever. Right? I'm not going to lie. These problems are going to get easier the more of them you do. Right? It's one of those things where the best way to make them easier is to practice with more of them. Right? You'll get a little bit faster, right? When we did that last step over here, let's see if I can use the highlighter properly. When we did this last step over here and just kind of took care of both bits of multiplication at the same time, right? That's a little shortcut, right? No, if I was just starting this off way back when, I might write that out as separate steps to make sure I didn't mess it up. But if you're able to do what we did in the highlighted yellow there, right? Just do 2 steps kind of in the same line, saves you the time. You get better and better at it as you go, right? Interesting. So what I might have you try, we'll go through this one together. So what we've got here, right, same kind of deal. We've got two different variables to plug in. We've got an x which equals 11, and we've got a y which equals 9. So I'm going to go ahead and just plug all that in. It's negative 22 divided by that x, which is 11, and then minus 8 times that y, which is 9. Right. And you might notice that, we've kind of been playing around with parentheses a little bit. I took the parentheses off of that 11 already, right? Because we don't need them. It's hanging out by itself. There's no negative that we need to keep grouped up with it, so we're okay to leave those. The ones around the 9 need to stay because we need 8 times 9, not 89. Right? So this one's not too bad. Order of operations. We don't have any parentheses we can do anything in. We don't have any exponents. Moving on to multiplication and division. Right? So the division, let's take care of that piece first. Right? 22 divided by 11 is just 2. Right? After that, we've got this multiplication over here that we can take care of. This is negative 2. Now minus 8 times 9 is 72. Last but not least, we throw them together, and what do we get? Negative 2 minus another 72. Right? So again, if you're having a little bit of trouble with that, think about the building, right? Ground level, we're 2 floors up, and then we're going down 72. Right? So we're going to end up way down on the bottom there. Right? We're going to end up at negative 74 if we go down 72. All right, so negative 74 is the answer we're looking for. Okay. Hopefully that doesn't seem super duper scary, right? Again, if you're somebody that has a little bit of trouble with negatives, if you want to use a calculator, that's no big deal, right? Negative 2 minus 72 more brings us to negative 74, right? No shame. Yeah. So, what I'm thinking is, if you haven't tried one on your own yet, try pausing here, try this one out, come back to it when you're done with it, and then check what you did against what I did. All right, so on this one, we've got that x is equal to 3 and y is equal to negative 2. I'm going to do the same old deal and plug those in. So we got negative 3, and then in parentheses 5 times that x, which is 3, plus 9, and then plus 10 times that y, which is negative 2. All right, we need the parentheses around both the x part and the y part here because they are multiplying, right? We need to make sure that we're not saying minus 53 and 10 minus 2, right? We have multiplication going on there. Okay, so I'm going to look in this first set of parentheses here, and inside of there, I'm going to start with the multiplication, negative 5 times 3. All right, so negative 5 times 3 is going to give us negative 15 plus 9, and then everything else stays the same. All right, now that we've got that taken care of inside those parentheses, we can go ahead and do that little bit of addition there. All right, negative 15, so imagine you're 15 floors down in the big building. You're going up 9 floors. You're still underground. You're at negative 6. All right. So again, kind of similar to where we were at on one of the previous problems, right? We just got a little bit of multiplication to do, and then we're good. All right. I'm actually gonna slap them into one step. Negative 3 times negative 6. Because they're both negatives, we end up with a positive 18. Bring that plus sign along. And then the other side with the multiplication, 10 times negative 2 is negative 20. All right. So this is actually where we can use one of those sign laws that we talked about back in the first lesson, right? That we have 18 plus negative 20. That is the exact same thing as if I said 18 minus 20. Right? So 18 minus 20, if I'm on the 18th floor and I go down 20 floors, I'm in the second basement. Our answer is negative 2. All right. So this one's kind of similar to some of the other things we've been doing. This is one where, again, I'm going to kind of, let's talk through this one too. I keep talking myself out of it. All right, it's the same kind of deal. We've got an x, we've got a y. We're going to plug them into the right spots. So this will be negative 10 minus 18 over the x, which is negative 2, and then plus 6 times the y, which is negative 4. All right, so, oops, I'm getting a little bit ahead of myself. Let's talk through this first. All right, so what I'm looking at here is that I've got some parentheses, but I can't actually do anything in them, right? They're just to kind of contain the negative. So what I need to do is think about, all right, I don't have exponents. I'm going to move on to multiplying and dividing. All right, so the first thing that we run into for multiplying and dividing is right here. So 18 divided by negative 2. So I'm going to bring everything else along so far. When we have 18 divided by negative 2, because it's one positive and one negative, our answer is negative. Right? We're going to get negative 9 there. Right? And then I'm going to bring along everything else just as it was. Right? So again, another case where we can use some of those sign laws that we had. Right? So you might notice that I have 10 minus negative 9, right? This double negative going on right there. When I've got a double negative, right, they kind of cancel each other out. So what I'm going to do is I'm going to pretend that that just turns into one big old plus sign. So now it's negative 10 plus 9. Much better. Right? So we did that division, and then we simplified a little bit. Now we were going to go ahead and take care of this multiplication that's hanging on to that side. So you got negative 10, now that's plus 9, and then 6 times negative 4 is going to give me negative 24. Right? Again, sort of similar to the division we just did. There's a positive times a negative, right? 6 times negative 4. So we end up with a negative answer, negative 24. After that, it's just adding and subtracting. All right, so we'll smush those first ones together. Negative 10 plus 9 brings us up to negative 1. So if I'm down a floor at negative 1 and I go down 24 more, what I'm going to find is that I am at negative 25. All right. So these can have a lot of steps that you need to be a little careful of, but I'm really hoping that they don't seem like insurmountable, right? They don't seem super duper bad. It's just a matter of being careful, taking your time. I know that when you get to math class, you're like, oh man, I just want this to be over sometimes, right? I get that way too, right? But this is one where it really pays off to be careful when you're working and keep it organized as you go, right? Oh man, it's everybody's favorite thing. Let's talk about some word problems. So what we're going to do with word problems is we're just going to kind of talk at like a base level about what do these things represent in these expressions. So in this one, Jenny's class is selling raffle tickets as a fundraiser to raise money for a field trip. The individual cost of participating in the raffle is given by this expression, 4t plus 2. Right? That's not 40 plus 2, that's 4t plus 2. Right? So what we want to figure out is what does the t represent in the context of the problem? Right? So let's think about this. Right? We're selling raffle tickets as a fundraiser to raise money for a field trip. The individual cost of participating in the raffle is given by that expression. So T, if I'm thinking about a raffle, T might represent maybe tickets, right? So it can get a little bit tricky, right? Again, this is one of those topics that gets easier the more problems like it you see. You're just trying to think like, all right, what's the situation? What in that situation might I represent with a variable? So T is something about the tickets, right? And in this case, I don't think it's the cost of the tickets, right? Because the T might be something that could change, right? T is actually going to be the number of tickets purchased. All right, so think about it this way, right? 4T plus 2, that's saying like, all right, if I bought one lottery ticket, I'm going to plug a 1 in there, right? It's going to be 4 times 1 plus 2. That'll end up giving me the cost it is to participate in the raffle, right? So how much money will someone spend if they buy 2 tickets? Well, when they buy 2 tickets, that means that my T is going to be equal to 2, right? So it turns into one of those problems that we were looking at a little bit earlier. So all I have to do is plug 2 in where I had a t. All right, so this is 4 times 2 plus 2. All right, so to buy 2 tickets, let's figure it out. 4 times 2 is 8. And then plus another 2 gives me 10. So it'll cost them $10 to buy 2 tickets. All right, not too bad. How much money is someone going to spend if they buy 10 tickets? All right, try that one out. Pause here and then unpause when you think you got it. So to buy 10 tickets, that now means that our t is equal to 10. Right, it's the same kind of deal. I'm going to go ahead and plug in 10 where I used to have a t, and then just simplify from there. And so 4 times 10 is 40, and then plus 2 gives me $42 dues. Right? That's really all we've got going on there. Right? So $10 to buy 2 tickets, $42 to buy 10 tickets. You could buy any number of tickets and figure out how much it should cost you. Right? Let's try another one real quick. Eddie wants to have his birthday party at the movie theater. Ooh. Movie theater has a discount for groups depending on how many tickets and sodas they buy. The cost for going to the movies is given by this expression, 6t plus 3s. So again, here we want to figure out what the t represents. All right, so I'm going to give you a little bit of a hint. T does not stand for the number of movie theaters. Right? Similar to the last one, T is the number of tickets. All right, so you might be noticing a little bit of a pattern, right? The variable is talking about the number of something, right? Meanwhile, the coefficient, that 6, right? Just to talk about that for a second, is the cost per ticket. Right? So T is the number of tickets you're buying, and 6 is how much they each cost. So if I bought 2 tickets, 6 times 2 is $12. 2 tickets should cost me $12. If I bought 10 tickets, 6 times 10 is 60, right? So sort of similarly, let's think about what S stands in for. So sometimes we might have to go back and reread the problem a little bit, right? Eddie wants to have his birthday party. Movie theater has a discount. How many tickets and sodas they buy. All right, so S probably stands for the number of sodas. Right? Same thing, the 3 is going to be the cost per soda. Right? I don't know what movie theater they're going to where you can buy a ticket for $6 and a drink for $3, but man, I want to go there. Whew, what a deal. So now that we've got that kind of taken care of, these next problems don't seem quite as bad. We want to figure out how much money will Eddie need if he needs to buy 13 tickets and 9 sodas. So let's break it down. 13 tickets. That means that T is going to equal 13. 9 sodas. That means that S is going to equal 9. All right, so again, it turns into one of those problems we were doing earlier. All I'm going to do is plug in those numbers where they're supposed to go. So it's 6 times that 13 for T, and then 3 times that 9 for the S. All right, so 6 times 13 is going to give us 78. All right, well, we'll say plus 3 times 9 gives us 27. And then all together, it's going to give us $105. Man, it feels like it costs that much to take like one other person to the movies, right? 13 tickets and 9 sodas for $105. Whew. Eddie really knows where to go. Let's try another bit out, right? Again, on this one, maybe pause and then unpause when you think you got it. Again, no harm in being wrong. Right? So on this one, we're buying 11 tickets. So my T has changed to be 11. 10 sodas means that my S is now 10. Same kind of deal, right? We're doing 6 times the number of tickets, right? Because that's $6 a piece. And then we're going to add on the cost for the sodas, right? So it's $3 for each soda times 10 sodas total. All right. When we go ahead and do this multiplication out, 6 times 11 is 66. 3 times 10 is 30. And then all together, that's going to cost them $96. Right? So hopefully that doesn't seem so bad, right? As always, be sure to check on Google Classroom for any additional stuff I might need to tell you about. If you have questions, be sure to ask them, either like send me an email or ask me in person. And I'll see you next time.